Hello everyone, Charmancy here. Today I'm talking about amplification attacks. Now, what's an amplification attack? So, with denial of service attack, the whole point of a distributed denial of service attack and a volumetric attack is I need a mechanism to generate as much traffic as possible. So, if I use a few machines and just run a simple ping command, I can generate some traffic. However, it's not a lot. So I need another way to exploit it. So I can use something like a botnet, where I have machines that are infected with a virus or something like that. And I instruct all of these machines that I have access to, say I have access to a couple thousand machines that are infected with a virus, I can tell them, hey, do this. But there are other ways that are more common and things to be wary of, because you could be part of this problem. So the first amplification style that I'll talk about is DNS amplification. Okay, so what DNS amplification is say you operate a DNS server. Okay. Now, say you do not follow the best practices, like in the NIST standard or some common practices, such as not allowing resolution for IP addresses that do not belong to you. So, for instance, if you're running a DNS server, you're making sure that this DNS server only serves networks that you own and control. Unless you're running a public DNS server, so if you want to be the next open DNS, then there are mechanisms such as rate limiting and stuff that you put in. Now, what happens in this case is that I have the attacker. Actually, let me put that in red. Okay, so I have the attacker machine here. And I have the DNS server, and I have the target. Okay, and this is A for the attacker. Now, what happens is, and this is not only one DNS server, so let's say that this drawing puts, say 100 vulnerable DNS servers. Now, what happens is that the attacker will send a spoofed packet to these DNS servers, and it's the equivalent of saying what happens is that they'll send requests for all of the DNS records that it knows of. So, for instance, requests for DNS can be very short, but the response is long. So I don't know the actual amount, but say you send a DNS packet and it's, I believe it's 32 bytes. But the response is something like 1 kilobyte. So I've amplified my original request by a factor of, let's say, 5. And what happens is that because this IP packet is spoofed, what I'll do is I'll spoof it with the target's address. So the attacker sends the traffic to the DNS server, but the DNS server sends the response to the target. Okay? So this is an amplification attack, also known as a reflection attack. Okay? Because what it is that I'm taking my data and I'm reflecting it right towards the target. So to the attacker, the attacker can literally be sitting there on a 2 megabit connection, but generating 500, 600 megabits of traffic because of this technique. Okay, so if you put into a real world example, if I meet you for the first time. I'm like, hey, how are you? What is your life story? What is your life story, okay, is a short sentence. But the response that you're going to give me is long. It's going to be like, you know, I grew up in Toronto, Canada. You know, my parents were engineers and blah, 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 blah. And that would be the same. But so if you put into reality, right, it's like me asking you what your life story is. So it's like, okay, tell me your life story, but don't tell it to me. Tell it to Bob behind me. And I do that 100 to 100 different people. So 100 different people are going towards Bob and telling them their life story, and Bob has not a clue why this is happening. So mitigation methods for things like this, for instance, to the DNS server, if I were going up to people, right, and I'm saying, you know, tell me your life story, tell me your life story, tell me your life story, maybe they'll turn around and say, hey, I've already told you this life story twice, so I'm going to rate limit you, okay? Or they can say, I don't want to, like, I'm not allowed to talk to you. Because for DNS, it's a big problem right now. There's DNS, NTP, the Network Time Protocol, which works in a similar fashion. Okay, so we'll go over NTP. So NTP, same deal. Works on the which is the Network Time Protocol, port 123, I believe. Target sends a request for NTP. NTP has a stupid feature in it called monitor or something of the sort. And what it does is the NTP server tells you all of the information it knows about other NTP servers. And that request is massive, and it will send it towards the target just like in the DNS amplification. There is a lot of concern. There's been a lot of bells rang by SANS, by the networking, the NIST standard. There's a lot of standard frameworks that say your NTP servers, unless public, should not be exposed to the internet, should have access lists and rate limiting, because with NTP, a lot of, in my experience, from all my experience and seeing DDoSes, NTP, DNS, these are common attacks with regards to denial of service. Now, with NTP, that request is bigger. What I'll do is in the description, there is a chart on the amplification factor of each protocol. So I believe, and don't quote me unless, you know, just read the table, but like NTP is a factor of 11, I think. So for every 1 byte that goes to the NTP server, we generate 11. So crazy, right? Now, with the NTP server, the problem is that there are a lot of NTP servers. A lot more NTP servers are exposed to the internet and poorly managed. But you also got to realize these aren't only servers that you know, companies are running. Another issue we're running into, and this is crazy, is consumer routers, consumer home routers, D-Links and Linksys, and you name it, right? They have vulnerabilities in them that can be used for denial of service. So SSDP, okay? So SSDP is a protocol for like the discovery within a network. Now, I'm sorry, I forget what it stands for, but I can look it up and I'll put it in the description. But nonetheless, what SSDP is another NTP or DNS style amplification. But SSDP is found on home consumer routers. Not only consumer routers, but it's mostly found there. And a lot of these routers, they're exposing services to the internet, or they're leaking services and stuff like that. And it's very simple to exploit that. If you ever go to Shodan, SHODAN, which is a like a search engine that was created where you can search up devices, so you can look up D-Link. And what this site does is scan the internet and see what open ports there are and stuff like that. So it's like one massive port scanner, but you find a lot more info. And you look at D-Link, it's crazy to find how many devices have, you know, the web login exposed to the internet. You know, another way of generating traffic, or SSDP is reachable. Like another growing concern is these home devices are being used in denial of service attacks, because, you know, some of them even have DNS servers, mini DNS servers that are running, and they're publicly accessible. So I'll leave that link in the description below for you to check out, you know, some of those devices, because it will make you take a step back. You gotta take a step back and say, okay, what am I part of the problem, part of the solution, right? DDoSes are on the rise, and for the most part, a lot of these amplification style attacks, these NTP attacks and DNS attacks, stuff like that, are normally because of poorly configured servers. Now, the one I would say, like the botnets, okay, well, that's a virus and stuff like that, and you know, we can raise more awareness about end users and remove the virus. But I'd rather say, oh, well, that was because of a virus than poorly configured DNS servers, because all you're missing is an access list. So the one other denial of service attack that this one gets exploited by Anonymous, and it's social denial of service. So social denial of service is when an attacking organization posts online saying, hey, do you want to be part of our DDoS? And if they get enough people that say yes, they'll use something like the low ion cannon. So what the low ion cannon is, just an app that you run in your browser, and it attaches your computer to denial of service. You enter the target, and boom. Now we get people willingly attaching themselves to a denial of service attack. You know, that's as simple as it gets from a hacker's point of view. You know, in terms of security, you know, there's ways of detecting that the low ion cannon is being enabled, but at a home, you know, that's when things are getting tough. See, the home internet connection is not something to be taken lightly anymore. At least in Canada here, we're rolling out 1 gig download, and some people have like 60 megabit upload. So 60 megabits per household. So let's say the market penetration rate is 30%, right? And that's equals up to like a couple million people. And let's say out of a couple million people, we get even 50% of them with some sort of virus or something like that. You know, these attacks are on the verge of becoming way more powerful. That's in Canada. In Europe, in Asia, and all these other places where a lot of this traffic originates from, their connections are massive. So these attacks are getting bigger and bigger and bigger. The last thing I want to talk about in terms of amplification and the rise of the amount of bandwidth these attacks have is Internet of Things. This is going to be massive. We're already seeing attacks that are utilizing Internet of Things devices because a lot of companies have not figured out better security processes. Yeah, some devices now were being used in attack. For instance, the one that was against the DNS attacks, also the ones on Krebs on security. They were finding that there were cameras, IP cameras, that had poorly implemented software that was exposing services to the internet, and they were using that as part of the denial of service attack, which it most definitely was some sort of amplification. So these home devices, IP cameras, DVRs, all these things where the home user goes home and port forward, this, that, don't change your default password, don't do this, don't do anything, just leave everything default. You have now a small computer that has web services exposed to the internet, and now the hackers are thanking you very much because it is so simple to exploit this type of device. A script on the internet scanning a few IP blocks that belong to an ISP yields a lot of devices that are publicly facing, and all I need is a small script to do some IP spoofing. So I hope this video explains in detail about amplification and the dangers that it's starting to pose. If you have any questions or comments, please leave them in the comment section below. You can also visit me on my website, SeanMancini.com, and I'm always available by email, Sean@SeanMancini.com. Thanks for watching, everyone. Bye.